Okay, so I want to give you a little hint as to how to solve problem 555. So the problem has a rod that's hanging from a cord and leaning against a wall, and you're supposed to solve for the distance h from the point where the cord is attached to the wall and the rod is touching the wall. So let's start this by drawing a free body diagram of the rod. And we'll draw the forces acting on the rod. So first we'll have the force coming from the contact at A that's perpendicular to the wall. Next we'll have the force B, that is the force of tension of the cord. And lastly, at the center of gravity, we have the weight. Now the trick to this problem is recognizing that there are only three forces acting on the rod, which makes it a three-force member. This means that along the line of action of A and the line of action of B has to meet with the weight. And so since I didn't draw it too well to scale here, what I'm going to do is just we'll shift the weight over a little bit so that it fits. So this is really not to scale. This distance this is the midpoint of the rod. And this point P is where they all intersect. So if we continue this up to the point where we have the cord contact at C, we know this distance is h. We know that this distance is s over 2 because it's half the length of the cord. We know this distance is s over 2. And I'm going to call this distance A. We don't know what A is yet. Now at the same time, I know that I can draw from B a line straight up and down. And again, this is really not to scale. So if this distance from here to here is A, that goes to half the rod, the other half the rod, this also has to be A. Move my label for point P. So I have A here and A here. And so now I have a right triangle that is sides H, some unknown A, and S over 2. And I have a second right triangle that's now 2A. This distance is also going to be h. Again, not to scale, but because this is s over 2 and this is s over 2 and it's the same line, that means this vertical distance has to be the same as this. And we know that the length of the rod is L. And so now I can use the Pythagorean theorem to relate s over 2 to h and A, and then I can relate L to 2A and H. And from that you can get a pretty simple solution to the problem. Note that there's no sum of forces, there's no sum of moments, and that's because we're taking advantage of the fact that this is a three-force member. All right, good luck.